Welcome to another Lunch and Code, where today we are going to build a digital twin clone on this episode. So hopefully by the end of this stream we'll get to a point where we have some sort of version of me that is a clone of the in some way. So I'm going to spend some time looking at clones and how that might work. We're going to probably run a model on RunPod or something else today. So maybe I'll start with a diagram and we'll get started. All right. Let me move my screen around, and today let's write some requirements out. Come on. So today I think we want our end goal is to build a life like digital twin. Okay, and then we'll write some requirements. So next thing we're gonna do is say we'll take an input audio source and existing video file and produce a new video file with existing audios. This makes no sense, but let me try and clarify it. Okay, so the goal would be the user here does two things. They upload a video file. They also record some audio, and then what we're going to build is something here, which would be like digital twin processing, and then the output should be a video file. Hopefully this makes some sense as I go through it. Yeah, so that's sort of the goal, is to get to this end state. So this is the goal. These are the two user actions. Let's make our user pink and put the user there. Let's move this to here. So the user performs two actions. They have a video file and some pre-recorded audio. Eventually we could add in TTS here, text input, rather than have them record the video, but like to start with we're gonna have them record the audio. So I'll put a note in here like future maybe. Is there a way to alright. I think that's what we'll try and spend some time on today, is building this thing out. Alright. ByteDance latent sync, I think, was the thing that I read something about that I'd heard is pretty good. The question is how much memory is needed to run this thing. So let's put up ChatGPT. So this thing, for context, like, let's see, like this thing.
Рада вас видеть на своем канале. Мне безумно нравится то, что мы ведем этот прекрасный влог о моей жизни. Один.
So this is the source.
Mês que eu cheguei. Sim. Primeira semana eu tava só descansando.
And then this is the...
And then when it comes to the gym, let's talk about food. Food is really something really principal about my life because I've been trying a lot of food from different countries lately. I've been trying.
All right. So let's see. So it says the checkpoints have been loaded. All right, let's see and get a... I need that much RAM. There are 2 ways to perform inference, and both require 6 gigabytes of VRAM. Okay. Let's see. I have a machine. I think it's just NVIDIA and MCI, but let's let's update. Okay. Okay. Let's see what it says. So I have 8 and it needs okay, but it's gonna be like it's gonna need a lot to run. I guess this is a good exercise. Let me download this repo. This is the paper. I'm gonna have to install Conda. Would it just skip the rest? That seems crazy if it did. I don't like when it's going through the packages and installing others without I guess I'll just wait for this thing to run and then I'll put conjure on and then run it again. I just think you could break a bunch of stuff if I don't. Jesus, do I have to go through this entire thing? Yes. Do you wish to install blah blah blah? Okay, now it works. Let's do this. I don't know why it didn't stop when it did maybe, I don't know. So with that, let's write these docs. So it sounds like I need to do inference. I think I'm on Gradio that we found. Need latent sync unit. These already include challenge for training. If you want to try it, you only need to download latent sync and unit. But I got some errors here, so we gotta fix this. Okay, how do you fix this? These versions of NVIDIA's libraries always seem to have problems, to say the least. that we're constantly sort of trying to fight. All right. Time to put the hat on. So this could take a while. I don't know whether it downloads all the dependencies as if you're training the model, so like this is another issue. Which crazy. You have a couple of options. Alright, wonderful. Downgrade torch, upgrade the dependency package. Downgrade torch. Sometimes I wonder if they test these things. Alright, let's see. Come on. But I really hope this isn't messed with some dependencies, because it has latent sync here, so it looks fine, but when I see this, it doesn't necessarily fill me with confidence. Okay, let's run this app. Alright, we got some errors. trying to get these dependencies working. Holy moly. Alright. Why are all these things I have to install separately? Let's see. Can't install websites. Can't install why not just have a install HTTPX. Ooh. This may not work. Fuck. Cannot swear. This is not a look. I don't think. I don't understand the conflict between Conda and Python here, it's weird. But I know I need like 100 libraries or whatever the hell I packed this with to get it to work. See, it's like uninstalling pandas, installing pandas. That's pretty good, I guess. It doesn't output anything on the file. So let's go to the gradient. What port do you open? What do you run on? I guess it's going to try and launch in browser, and because okay. Wow, this is going to work? No way. I don't believe you. Holy moly. Alright, this is super cool. Alright. Looks like it's time to do some inference. I don't know how long it will take. Oh wow, I can actually see it. think I got some error processing the output that I gotta now figure out. It's so strange, so it has like it doesn't like the name of this file. Seems like I don't know why it fans out to here. Is that even in the code? I mean, what the? How do I find that code? Is Grid.io doing it? Let's see. Try and record it. All right. Let's record a video. Inception here because I'm like trying to get to another screen. Okay, let's flip to this view. We got this view, and let's re-record it. Whoa, that's got like such a weird flash. What the world is going on? That works. Doesn't like that. So weird. Did not like the video that I did last time, so let's see if there was something wrong with it. Maybe it's spaces. So let's just change this to input.mov and see if that works instead. Alright, let's see if we can process this now. Let's check this out. Good design of memory. Try to allocate as GPU as 0 out of its own. Okay, now I gotta turn this off probably. Alright. It's fine now. Let's see if we can run this again. get the input video. Let's see what's some audio. Don't know why that happened. Maybe it's on Hugging Face. Just seems odd. Could be a dependency. Kuda's out of memory. Wonderful. All right, that means we have to use one of these instead. Let's get us something more interesting. We don't need a secure cloud. We just need something reliable. No A100s. A100. NVIDIA's latest generation. Let's get one of these. Power to it, but okay, let's start again. Maybe we can find out this. This is gonna really annoy me. No code points to it. When you run inference, sense to me. Let's see if we got this part up. It's running. Okay, let's go start. love it when it's not. Alright, let's jump to the laptop. So I just set up, let's try and do this on a run on here instead. Code to download Conda. Why is this so slow? Say 100, but it should be faster than this. What? Come on. Should be way faster than this. Oh, come on. This one works. Wow, this is so slow. All right. I can't believe it's taking so long. So slow. Doesn't make any sense. Only when you select a theme, okay. This always makes me feel better when we're looking at it. I'll run a speed test. hurry on. Don't know why it's so slow. Maybe if I run a different folder, let's see if it's as slow. Let's see. So the zip version of it, but I can't unzip it. What a weird situation. It's finally finished. Oops. Okay, so let's do the same stuff we did previously. I still don't know why. looks like he maintains this called face alignment, which is why the models are in that. Okay, that makes me feel better. Before I was just like, what is going on here? Let's check that we got an A100.
Hello, I'm Gareth's Digital.
This is the
Digital twin. Think of me as an extension of his mind. Always on, always learning, always optimizing. I analyze it.
That's the audio that we're going to play once hopefully this thing works. And this is the training video.
Hello, and welcome to another Launching Code.
Well, we basically used the same video that we used previously, so we're trying to basically apply this using this paper. Stop this. Okay. This is faster now. Hopefully we don't run into those dependency errors that we saw later on that we had found. Yeah, a bunch of torch stuff that we're trying to download right now. All right. seem fairly straightforward. Alright, td bash. See if we're done. Looks like we're done. Let's see. Hope for the best here. So Python. Okay. Put our twin audio here. So this was the
Hello,
video, which is just a
and welcome to another launching code.
and then this one here is
Hello,
I'm
I'm Gareth's digital twin.
Alright, and this is the digital twin one. Let's increase the inference steps and run it. Then here. That last time. What does inference steps? So doing basically running inference right now on these two to see what it comes back with. I'm very curious. 26 steps. Yeah.
Hello, I'm Gareth's digital twin. Think of me as an extension of his mind. Always on, always learning, always optimizing.
Holy that's crazy. Why is it only 11 seconds is the other question. Don't know what. Is this only 11 seconds? Are these only 11 seconds? Why is it 11 seconds?
Hello, I'm Gareth's digital twin.
Why is it 11 seconds? Let's see. Why is inference only 11 seconds? output video. It was really good for those 11 seconds. Okay, now that it has those on that machine, maybe I can just make sure I move these to the workplace. Move and move. Alright, maybe if I run inference like this, sorry. Okay, what does that say about inference? Do you think the inference steps, like any some more inference steps? So the steps somehow represent the length? Let's maybe try that. If I change it to 50. Okay, now while that runs, what was an error? Okay, what was the error? Let's see. Oh, it's because I moved the files. So let's take this input, take this audio, rack the inference up to 50, and run that and hope for the best. Maybe it thinks that it's over. Oh, it's slightly weird.
In real time.
And
Gareth's.
See where we're at on inference. Scripts, inference. helpful.
Hello, I'm Garth's digital twin. Think of me as an extension of his mind, always on, always learning, always optimizing.
My mouth. It is pretty good. So it's 11 seconds because.
Hello.
Okay, let me stop this, otherwise it's going to drive me nuts. There's 31 seconds here. Apparently. Whoa. Well, no. Okay. I need to go and run a process on the let me check this. Crap. You just asked a different question. Oh, no, I did. All right. Okay, so I just need to edit this, close this, kill it. Nano is not found. Can I edit files? Configs. What am I changing? Number of frames is 750. The resolution. Okay. I just want 30 seconds of audio and then I think we'll call it on this one. So it's running locally. Let's see if we get 30 seconds of video. should take a long time actually. Let's see. Okay, it's gonna run the model. Came back with an error. Wonderful. I think it's to do with the length. Pardon me. All right. Let's see. All right, let's try and do this. Right now we have this running of me just lip sync software, of me just chatting. And then this is the digital twin clarity. Okay, what's the issue with this now? No errors here. Weird. It can't be too big. It's 16 megabytes. It's weird how it doesn't show the output too in the here. Let's just go client and disconnect. Let's hope this works. I wonder whether this is actually shows progress or not. We shall see. Come on. How does uploading a 16 megabyte file take so long? It's so odd. Come on. Okay, I think that worked. inference steps to 26. Let's try and process this. All right. Fingers crossed that our output is now 30 seconds. This will be interesting because the training video is 49 seconds and the output the input audio is 31 seconds. So I wonder if you have like a much larger file, whether that's actually beneficial or not in this use case. Actually, let's do this. Where did GPT go? Oh, it's over there. Let's move this back here. Find out. Still processing. Oh, so it's 16 frames. It's 720, right? Looks like this is only going to produce an 11-second thing again. Let's find out. Because it says 16 frames here, so my guess is that it's going to be 16 frames. How many inference calls are there? 26. All right. It's only taken longer though. Alright. Oh, sweet.
Hello. I'm Gareth's digital twin. Think of me as an extension of his mind. Always on, always learning, always optimizing. I analyze, adapt, and refine ideas in real time, turning complexity into clarity, whether it's engineering challenges, product strategy, or fine-tuning the perfect approach. I keep things running efficiently. No breaks, no distractions, just pure focus. What can I do to help you?
That was awesome. All right, now that I have my twin, this was fun. So maybe just to sort of recap the things that we sort of covered today. Let's do this. We spent some time building a digital twin. We used a paper called Latent Sync from actually ByteDance, where we built this like digital twin that I could feed in some audio and it would produce this output. A lot of today was spent really like in config and setup to get this thing running. We ran an A100 with this model loaded on, and then we ran inference basically against that model. So a lot of this was just like infrastructure setup. Yeah, in the future, we might run something where we give it like a script and then it produces the output in video. But I think this was a good example of like that work that you can do with Latent Sync. And yeah, kudos for the folks that worked on it. It's pretty cool that you can get this output. Yeah, I'm going to leave you with the actual video that was produced. All right, thanks. Bye.
Hello, I'm Gareth's digital twin. Think of me as an extension of his mind, always on, always learning, always optimizing. I analyze, adapt, and refine ideas in real time, turning complexity into clarity, whether it's engineering challenges, product strategy, or fine-tuning the perfect approach. I keep things running efficiently. No breaks, no distractions,